All right, this is Algebra, lesson 7.4. Okay, Algebra, lesson 7.4. This is polynomials. Okay, we've been working with monomials this whole time. What's a monomial again? What does mono mean? One term, right? All these things we're doing is one big giant term, right? Okay, monomials. A polynomial, poly means many. Poly means many. So more than one term. That would be something like this. 4x squared. What is 4x squared? Is that that's a monomial, right? Because it's all multiplication here. Agreed? Nothing but multiplication. But if I said 4x squared plus 4, this is now a polynomial. It's a polynomial because there's more than one omeal, right? There's more than one meal. Okay? And so there's one term here. That's a monomial. That's a monomial. More than one monomial makes it a polynomial. Makes sense? Okay. More specifically, this is called a binomial. Bi means two. That's a binomial. Something like this. 5y squared plus 3y minus 10. How is this a monomial? No. That's a polynomial. Okay. But this is more specifically, this is three terms, right? Three monomials, which makes this a trinomial, right? So those are the three that we're going to be working with almost exclusively here for the rest of the year is trinomials and sometimes binomials, but we're going to be dealing with polynomials a lot. You just have to recognize how do you know, when do we decide, what decides whether or not it's a binomial or trinomial? What separates the monomials to make them these binomials and trinomials? Plusing or right, adding or subtracting, right? It's really all adding. Remember, subtracting is just adding, right? 5 minus 4 is the same thing as 5 plus negative 4, right? Subtraction is just addition, just like division is just multiplication, right? We've talked about this. That's why there's like you talk about the commutative property. Why isn't there a commutative property of subtraction? Why isn't there? Because it's the same thing, right? It's the same thing. It's all addition, right? Subtraction is just addition, right? So, and why is there no, commutative property of multiplication or of division? Because it's just all multiplication, right? If I have 8 and I divide it by 2, how can I turn that into a multiplication problem? Isn't that 8 times 1/2? Instead of divided by 2, it's 8 times 1/2, right? Because 8 times 1/2 is still 8 over 2. Do you see what I'm saying? Right? Okay. As long as you remember that. Anyway, okay, so here's the deal. Some things you need to do is recognize this. They'll ask you, is this they'll say, is this, determine whether it's a polynomial, express the polynomial as a monomial, binomial, or trinomial. I guess, so here's the deal. Even monomials are polynomials. Okay? So here's the deal. I'm going to give you this. You tell me if it's a monomial, a trinomial, or a binomial. Okay? Monomial, binomial, trinomial. 8y squared, y, z to the 5th. There's that one. And then 2, tell me, 18x to the 4th, y to the 5th, z, plus 1. And then 3, what is 5 plus x plus y? Okay, you should be able to look at this, really tell me, what is number 1? 1 is a monomial, right? It's big, but it's just all multiplication. That's a monomial. 2 is a binomial, right? There's a plus sign separating the two monomials. And then 3 is a trinomial. It's not. It looks simple, but no, there's 1, 2, 3 plus signs, right? Makes sense? Trinomial. I think you guys have that. That's not difficult. Okay, here's the deal. One thing you need to understand is you'll need to know this later for when we do different formulas and stuff. You need to know the degree of a polynomial or of a monomial, the degree of a monomial. If I have this, I'm going to go 5x squared y. This is a third degree monomial. What does that mean? Sorry, this is a second degree. Let me see really quick. Hold on. Let me pause this. Let me look. Okay, no, I was right. This is a third degree polynomial because you add up the total amount of exponents here. How many total? You're going to add up this. This is 2 here, and there's a 1 here. Does that make sense? So that's a third degree monomial. If I gave you this, if I said here's 2x squared y to the 5th z to the 7th, this is a 14th degree monomial. Does that make sense? You're just adding it up. If I gave you this, if I said x to the 8th, that's an 8th degree monomial. Eyes are up here, guys. This is an 8th degree monomial. Does that make sense? Okay. So no matter what if I give you this? Negative 3 x, y, z. What degree monomial is that? Third degree monomial, right? There's an x, there's a y, there's a z. Isn't there a 1 on each one of these? We add them up. That's the degree. Okay. And then, okay, so then here, I'm going to give you one, see if you can do it. 7x to the 5th, y, z, and then do, and then 2rt minus 3rt squared minus 7r squared t squared. I want you to tell me for each one of the monomials that you see, each monomial that you see, I want you to tell me the degree. So like there's a monomial, there's one, there's, you know what I'm talking about? So there's one, there's one, there's one, there's one. Give me the degrees for each one. Okay, makes sense? And then I'll tell you what we're going to do with it once we get done with that. Okay, so you're watching. Here's the deal. This is important. This right here, what is the degree monomial here? That's a 7th degree monomial, right? Okay. Here's the degree. This is a polynomial, agreed? This guy is a 2nd degree, agreed? This guy here is a 3rd, and this one here is a 4th. That makes this whole thing a 4th degree polynomial. Whatever is the highest monomial, that's the degree polynomial it is. So if I give you this, 2x to the 5th plus y to the 4th minus 3z to the 3rd, a to the 3rd, what degree polynomial is this? That's a 6th degree polynomial. You look at each one and you go, that's a 5th, this is a 4th, this is a 6th. It's a 6th degree polynomial. Does that make sense? Does that make sense? Okay. Now that we have that, this is all just stuff you have to memorize. You know what I'm saying? Like, this is not math. I mean, you can add. Here's the deal. There is an order, there is a standard form when you write a polynomial, okay? The standard form for writing a polynomial is to put it in the greatest degree first, going down, right, in a descending order. So on this one here, you would write this polynomial as minus 3za to the 3rd plus 2x to the 5th plus y to the 4th. Do you see what I'm talking about here? You put it in descending order. This is the degree, this is the 6 first, 5, 4. That's how you write it. Make sense? You just put because remember, aren't I allowed to move these things around? Am I allowed to move these things around? I am, because we're just adding and subtracting, right? That's the commutative property of addition. Just move around. Make sure you keep the sign with them. Also, in that big question there, what I just had, where it was, I'll go back. There's another thing you need to know, and that is the leading coefficient. Okay, the leading coefficient is once this thing's been written out in standard form, once you've written it in standard form, what is the number that comes in front of it all? What's the number that comes in front of it all? -3. The leading coefficient of this polynomial is -3. You can't find the leading coefficient until you have put it in standard form. Question busy. I told you put them in order, a descending order. The biggest first, then the next smallest, then the smallest.
How is it 6? How is the degree 6?
Because it's z to the 3rd, a to the 3rd.
What about
These are x to the 5th, that's just 5. And this is y to the 4th, that's 4. It's how many total variables multiplied by each other. Look, pay attention. X, Y, Z. That's a third degree monomial, right? Now it's a 6th degree monomial. Are you paying attention over there? Now it's a 6th degree monomial. Now it's an 11th degree monomial. Now it's a 105th degree monomial. Right? How many degree monomial is that?
Wasn't it 15?
Right, 15. Right, what'd I say?
11.
Sorry, yeah, 15. Now it's a 105th degree monomial. Make sense? Makes sense now?
But why is it 6 though?
Because there was, I'm confused. If there was z to the third, a to the third,
And exponent. But why?
That's why he was confused, Mr. Duncan. He forgot the 3 above the Z.
no, it was there.
No. Why? What about the line in front?
That was 5x
Yeah. Well,
to the 5th. That's a 5th degree monomial. We're not adding that with anything else. There's no, it's the total number of variables being multiplied by each other. That's what determines what degree it is. I'm confused as to why you're confused.
why did you only take the 6 and not the 5 as the degree?
What?
See, in the polynomials, why did you only take the 6, not the 5? So, yeah, but how did you know which one was the degree? If there's something else.
The degree is the exponents added together.
Yeah. So they're all separate degrees, and you put the highest degree and then you go down. Each monomial is different.
So the highest one is the
Highest one goes
The highest one is the last one because it's a 6th degree. And then
How many total variables are being multiplied here? Dizzy, how many total variables are being multiplied there? 5. How many total variables are being multiplied here? How many total variables are being multiplied here?
6.
That guy's the first one, he's second, he's third.
So it asks you find the degrees.
Then it's the highest one. Whatever's the highest one. He's the one who's in front. This is a 6th degree polynomial because of that, whatever the highest one is. Make sense? And you would know that because no matter what, you're always going to put this in standard form. And so it's going to be whatever's the first one. Try one. Try writing this one. How many degree is this?
0.
No, right? No degree here. Not. And if it was 8x, then it would be a first degree, right? But if it's just a number, no degrees, right? Okay. So what I want here is this. You're telling me, I'm going to want this. I'm going to want you to tell me, number 1, degree. And then 2, I'm going to want you to put it in standard form. And then 3, I'm going to want to know what is the leading coefficient. Okay, that's what I want. Okay, so the first one says the degree. So I'm going to look at each one of these and decide which one of these is which one's the biggest one. Which one's the biggest one? The 4x to the 4th. So how many degree polynomial is this? It's a 4th degree polynomial because of that guy. Okay. Oops. 4th degree. And then I'm going to write it in standard form. So I got to find it. This is a 4. That's a 2. That's a 1. That's a none. So go 4x to the 4th minus 2x squared minus 3x plus 8. You can't mess up on those negatives, right? They each have to take their sign with them when you ship them around. Agreed? Makes sense? Okay, so there's standard form. And then the leading coefficient would be 4, right? It's whatever's in front. Did you all get that? Raise your hand if you got that. Does it make sense? Does it make sense?
Yeah, I just didn't add the 8.
Does it make sense, though? Okay. Try this one. Here's a good one. Last one I'll give you, and then I'll let you guys get started on your homework, because this is really kind of simple. Okay, so we have y plus 5y to the 3rd minus 2y squared minus 6. All right, here we go. So the 3 things we're doing again is to Tell me what degree polynomial is this? A 6. Why? Because that's the biggest one right here, right? So it's a 6th degree polynomial. Okay, and then how do I write this in standard form? Got to go in order, so that would be a negative. What I would do for real if I were you, what you've written it down is you go, okay, there's a 6, there's a 3, 2, 1, 0. Okay, so now we're going to go negative 7y to the 6th plus 5y to the 3rd minus 2y squared plus y plus 10. Right? Just put them in order. Grab their signs. They've got to go with them. And then what is the leading coefficient then? Negative 7. Everybody get it? Make sense? Okay. I will let you guys get started on your homework then. So you shouldn't have any tonight. This might be too short. Let me look. Yeah, I'm going to go 20 to 46 even, and it's page 427, okay? Page 427, whoa. 20 to 46 even.